Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
Welcome to the Decode Podcast. We've got a special one today. We are joined by two of the members of the Rise and Grind crew. This is the team that recently competed in a kind of very special event in our industry put on by EMAC, and it's a Bright Manufacturing Challenge. So we're excited to have you guys on. Welcome aboard. Ethan Chung and Alex Wan, and a couple of your colleagues are missing, so you can mention them when you give a little background on yourself. But as I understand, your crew is made up of all EE students and maybe one ME as an oddball in there.
Yeah. So, hi, I'm Ethan. I'm a sophomore at the University of Minnesota, and I study electrical engineering.
Hi, my name is Alex. I'm also a sophomore at the U of M, and I also study EE. And then our other members who aren't here right now are Kevin Vo. He's the Mechie major. Levi Crow, and then Raymond Zhao. They're both EE, and I think they're seniors.
Very cool. And you guys just recently pulled off a W in the Bright Manufacturing Challenge, or at least the first phase of it, right? And I understand that secures you a spot to compete in the finals in Rosemont and at SMTAI.
Mm-hmm. Yeah, we're excited for that.
Very cool. Yeah.
Well, I know Daniel has a question that he's itching to ask. Do you want to launch us into this, bud?
Sure. So I'm wondering how the project was set up. Like, how did you guys balance performance in your design and like best practices in design when it comes to that? But how did you do that within whatever budget and time constraints you were given for this?
Well, it took a lot of like researching, contacting with each other. We planned a lot on Google Docs. And also, I think one of the most helpful tools that we utilized was AI. So we use like things like Perplexity and ChatGPT to give us like quick access to the important informations in things like data sheets and like quick summaries of YouTube videos that would potentially be helpful for whatever we were working on.
Oh, it was definitely a lot of learning. Because round one, which we competed in, was a month long. So we definitely did a lot of research during like the first week or two, because one like deliverable of the challenge was like your whatever you're creating had to have like a really unique creative additional feature, and that's something that like we put a lot of thought into, and we researched a lot, and we really wanted to make that stand out from other teams, because like there were like only a handful of routes teams could go in, but we spent a lot of time on that.
So for the audience, can you actually just kind of walk us through like what the deliverable was, what the objective of each team was, and kind of what the scope of the project was in general?
Yeah, so the challenge was a month long, and each team was given schematics and components and a base board that they were able to work on, and so each team was tasked to create an additional feature, which was anything that could accomplish some sort of like task, and like only one task. And the board itself, like the main board, was the focus of the project was to create a line following robot using the PCB as like the chassis of the robot. So we worked on that.
What a line following robot is you have a track that is on a white background, and it's made up of black tape. And then the robot uses these things called infrared sensors that point to the ground. And then while they're facing the ground, they send feedback based on what color what color it's looking at. So if you're on the track, for instance, it's going to be black. So then it's going to send that back to the microcontroller, and then it's going to let them know that you're on the track. But if like you're on a turn and then the sensors see white, then it's going to let the microcontroller know that you're off the track, and then you're going to have to code like something to help it adjust back to the track. And
so you actually code the firmware and everything into the microcontrollers. So it's how well and efficient your coding is plays a big part into how fast it processes the information and makes the right decision, hopefully.
Yeah, that's the cool thing about this challenge. Like, they give a lot of focus on the hardware and the firmware. So like, it's like you're making sure that you're strong in both aspects.
Yeah, it's cool. That's cool.
I was fortunate enough to be able to. I know all three of the judges, and I don't know if you guys got to meet John Watson at all.
I talked to John a bit. Over messages only though.
Did you get to meet any of the judges at all?
We didn't.
Okay. If you guys
Did you
end up
talk
losing,
to any of them at all?
I don't think so. No.
Okay.
we had one of them on last week, and it was interesting to hear from his perspective on how he was grading, because, and I was able to see the outline that you guys were given to basically follow these suggestions, right, or rules, right, and this is what you're going to be graded upon, this and this and this, and it was a long list. It wasn't like a short, little paragraph here. There was like a lot of rules for you guys to follow.
Yeah.
And it was just cool to see, like, they gave you the bare board, and then he even showed me some of the Discord that was going on, and that thing looked kind of funny. You guys had some like funny memes in there, and it was a good time.
Kind of reminds me of ours.
Well, one of the things that kind of shocked me about, is what you guys talked about early on, is about like the creative part to it. And one university created something that was pretty cool, but it's not functional, right? But the grading was based upon how creative it is, so it was kind of interesting to see how they were taking it on that side of the aspect of, they thought outside of the box, right? That was the most important thing on that, and it was interesting.
Yeah.
So are you guys nervous at all about the timeline? Because if I heard what I heard correctly from John, you have an hour to assemble this thing as well on the floor?
I believe so. We haven't gotten much details about how the final round is going to look once we're in Chicago, but we'll see when we get there.
I mean, that's kind of intense. So you guys got good hand soldering and quick with it. I mean, it's not a crazy amount of parts, but it's not a little amount of parts, right? It's
Me and Alex have spent a decent amount of time soldering previous PCBs, so hopefully that'll give us like an edge once we get there, but I don't know. Anything could happen on the spot.
Yeah,
sure.
We've done a little bit of SMD before, but definitely not enough to like say that we're good at it.
Well,
Funny
Daniel
story.
and I cheat, right? Like, we have the pick and place machine, and
Yeah.
and that thing just does this thing, and then I got that nice reflow oven, right? So
Yeah.
and the stencil printer too, that helps out as right. So it's if I'm touching an iron, I mess something up during that process, pretty much, unless it's like no, not even through hole, because I have selective solders. So if an iron's being touched, something got messed up, or it's a hand build, which is extremely rare for me. But are you guys allowed to talk about your custom feature, or is that like top secret until the end? I was just curious about that.
Yeah, we could talk about it. If you want, we could show you our Altium window right now.
Please do.
Yeah,
All
most
right.
definitely.
Yeah, maybe while you're pulling that up, I can throw a quick question at you that's related. In regards to this custom feature, you mentioned that you're given kind of a kit, right? Some components, maybe a board. So do you have the ability and freedom to source outside of that kit, or are you limited to just what you're given?
You do have the ability and freedom to source outside of the kit. So the custom
Wow.
features basically it can be just like any components you find. You'll see what we made and probably understand it better too.
So
I love CAD, man. Just the look of it. Can you just do me a favor? It's like one of my favorite things in life is to spin that bad boy in like a 3D aspect. I don't know what it is, but my EE at my shop, I'm like, dude, spin it. I want to see it spin, right? And I want to zoom in and out. I don't know what it is about it. It's just it's just so cool. I just love it.
So are you guys allowed to change anything from round one to Chicago, or is it all, everything has to stay exactly the same?
I believe from it was like a week ago, there was a DRC checks. So that's when we changed everything, and now everything
Ethan,
now they're like ready. They should be like buying them and shipping and ordering them now.
Ethan, are you able to show the original Gerber files that they gave you, like the original layout?
Yeah. Actually,
Then we can
I'm
look at
not
like the
sure.
base and then the additions.
I don't know if I could pull that up. Alex, do you know of a way to get the original Gerber files?
I don't think they have those available.
Yeah, our board has components on both sides. And the cool thing about how they set this up was they made the PCB the actual chassis. So we're not housing the PCB in anything. It's just all the motors and stuff are going to be like connected to the PCB like via these nails or holes.
Okay.
For once, a mechanical engineer and a hardware guy got together and decided to make something.
Yeah.
Instead of one of the others saying fit this in this box, or make a new box, right?
So are there switches on both sides? Is that what I saw? There's one there, and is there?
Yeah, there's a
one
button on the
bottom
top, and then there's a power switch on the bottom.
I've seen a crystal in there too.
Yeah, there's a crystal.
Yep.
What is the crystal used for? I mean, I know timekeeping and everything, but like, how's it incorporated into your design?
It's for the microcontroller. I'm not sure. Or I didn't really do too much research on the the base components. Like they give like exactly like why they picked that crystal, but it's for the microcontroller.
Why don't we do this? We'll give you guys the floor and just kind of you take liberties to narrate us through what we're looking at and kind of why you made the decisions you did. If you can try to be conscious of the fact that some of our listeners are only listeners and won't be viewing, and try to provide some verbal color to it as well, that'd be awesome.
So it's a green circuit board. I don't know if you guys seen that.
Yeah. So like towards
who's Kale?
Kale is our robot name. It's
okay.
You're like Kevin, Alex, Levi.
Does anybody like eating kale at Minnesota?
Well,
it's the gopher. The gopher probably likes to eat kale, right? So
probably.
I actually just had frozen kale for lunch today.
Did you really? Frozen? Frozen? Did you reheat it?
Well, yeah, I heated it up, but like it came frozen.
Oh. Would you get that at Costco or something? That's a wild choice.
I don't get the groceries, but I'd assume it's from Aldi's.
I like Aldi's.
Okay.
All right. Do you want to start off by talking about the power, Alex?
Yeah, I can start off with the power. So like we placed our power section towards the middle of the board because the motors are towards the back and we have sensors at the front. So I was just thinking power in the middle. It goes both ways. And then adjacent to the power, like towards the left side, is the motor controllers. And then our microcontroller is also in the middle. We have something for the sensors to pass through, and then we also have the photoelectric sensors at the front.
Can't quite tell. Is that main microcontroller? Is that a DF or a QFN, a DFN, or are there actually leads on that?
It looks like a QFP.
Yeah, I think there are leads on it.
Oh, that's a QFP. Yep.
Good eye, Elias.
And then oh yeah,
go ahead.
We have a JSC connector at the back, and then we also have another power connector on the side, and those lead to our additional feature, and those use SPI communication for the JST.
And cool side note. So the additional feature, like you could really do anything you want with it. Most teams stuck with keeping the additional feature on their main board, but we wanted to do something with encoders to help our car drive straight, but that required the encoders to be facing the axle like perpendicularly, if that makes sense. It'll make sense once we show our additional feature board.
The edge connector's giving it away a little bit.
Yeah. So how we decided to work around the encoder problem was we created a whole new board, and this is a 4-layer flex rigid PCB.
So you
Sweet.
created this
Flex?
board from scratch. This wasn't part of any initial package or design that you were given. This is your baby 100%.
Yeah,
Oh,
100%.
very cool.
What made you
That's-
want to go with rigid flex?
We were looking for different ways where we could have the encoders face the axle while being attached to like a PCB. And one of our other alternatives was just using like connectors, like wires, but we thought that looked a bit clunky. And also like flex rigid was something we've never seen before, and we thought it would be a cool like thing to experiment in this challenge. So we ultimately went with it. And then
Yeah, I think the main reason was just it looked cool.
Yeah, they look amazing.
yeah. And check it out. If you press 5 on the numbers, you could get it to flex.
Oh wow! Look at that!
That's
Look
cool.
at that!
Oh,
Oh,
now
yeah.
that is a neat trick
That
right
is
there. All of us
awesome.
ooh
Look
and
at
ah.
This is why I love CAD, man. It's awesome.
I know, it's cool.
This was my favorite thing to do for like a whole week when we were making this. Like I just go back in after the work session and just
Click.
look in awe.
Yeah,
Like seeing
you're gonna do just fine as an electrical engineer.
Yeah.
I'll tell you that. That's all you need right there.
Thank you. But yeah, basically we housed the encoders on the side wings, and we made it so that they perfectly line up with the axle on the TT motor.
Nice.
So we'll attach a magnet onto the end of those axles, and then the magnetic encoders will send the data back to an onboard microcontroller. There's a second microcontroller on here, by the way. And then that processes the data, and then it sends it back to the main MCU.
Now you got to solder all this as well, though, too, right? Within an hour.
Yeah.
I think we could solder this before competition because
Oh, you're
Okay.
right.
yeah, we
Okay.
did before.
But none of what is on the screen right now was included in the kit.
No, this is everything we made.
That's good work.
That is
Yeah.
good work.
Impressed.
We also have a little LMU sensor right here. So this has a gyroscope and an accelerometer. And that's also just going to feed data back to this MCU, which will
Yeah,
feed
gives it
to the-
positioning data at all times. And
Yeah, exactly. It's going to be like hella hard to code, but like we'll get through it.
nice.
Are you guys also using AI to assist in the coding?
Probably.
That's what we're looking at.
I don't think me and Ethan haven't done like a ton of firmware, but we've done like a little bit of PCB design coming in, so firmware might get us.
Yeah.
Are you guys gonna try to write it in C, or is it what type of language are you thinking about?
Python.
Probably C. I think.
I'm most familiar with C++, so that
C++.
might be what we stick with. Or C.
Now, talk to us a little bit about the hardware, I guess, and by hardware I mean the actual drive, the drivetrain. Is there anything you can do there? Do you have any flexibility in terms of what types of motor you use, or what type of wheels the unit has on it? Is there any room for creativity there, or are you kind of given a set of motion hardware?
So the wheels and the motors are part of that like base package. So all teams will be using the same wheels and motors. So we can't change those, unfortunately, because apparently those motors like kind of suck.
Yeah. Well,
Is this any different from a maze? I've heard a lot about like the maze. It's like a big, big in conferences and stuff like that. Would you say that this competition's a little bit different than that, or?
I'd say like it's a maze, but 2D. Like there's no walls, but you have to
Yeah.
follow a predetermined path. And it's all going to be autonomous. Like we can't like look at it and pre-code, like say, oh, there's a turn here, turn 90 degrees.
Oh
like
wow!
Yeah, so
when it
it's all,
starts, it's on its own. It's deciding which way to go on its own, right? You're
yeah,
not. There's no
100%.
remote control of it or anything. That's the actual project, is having it process the image that it sees and know what to do. And so does the map usually have? I think I've seen videos like this before. And if it leaves the line, do you have to go correct it and like put it back at the start, or put it back where it was, or is that just a automatic loss, or how's that get handled?
Leaving the line, well, one of the options is picking it up and putting it at a checkpoint, I believe. I think there were checkpoints there. Correct me if I'm wrong, Alex.
You guys are just winning, so that was for other people to figure out what happened.
We'll see when
Yeah,
we get there.
hopefully our bot doesn't get lost. I think there are checkpoints though.
And then there's another way that we were thinking about how to solve the possibility of the robot falling off the line, and it was using like PID. Shoot, what was the acronym for, Alex?
A PID controls.
So proportional something drive, right?
Yes. So it's like, yeah, basically it'll like constantly.
Let me search it up really quick.
Yeah, what is that? Proportional integral derivative controller.
Have you guys had that rigid flex board made yet? Have you? Because it's kind of crunch time, guys. You know.
Yeah, we ordered it last week.
Okay. So it's getting made right now. Because rigid flex can take some time sometimes.
Yeah, I think the expected like shipping time was like 17 to 16 days, which is a while.
Yeah. It's not quick.
One of the other things about rigid flex is that it could get really expensive.
I didn't want to say it. But when I see, yeah.
When
You pay for cool.
you tell him, Alex, you're the one that
cool is novel and expensive.
Yeah, I put in like I remember I got the Gerber and I put in the quote and I was like, I feel like something's wrong. It's like
Software broke. What happened?
Yeah, I mean, if you think about it, the board you showed is technically like 5 boards, right? You know what I'm thinking? It's those three regular FR4s.
The chassis, the main body, then the wings, and
the 2 flexes, right, that are connecting everything. So, and then you're like, hey, sandwich these all together, right, and connect these layers. It's a process, man.
Do you have to hand solder?
I believe so. There hasn't been that much communication about how we're going to get the components onto the board, but hand soldering seems like the most probable.
I'm trying to think of how I can give you guys a competitive edge. Send you a little hand stencil and a hand squeegee.
That'd be nice.
That would help.
Yep.
Have you ever done like hot iron, like just use hot air and an iron, or I mean not an actual iron, but like a what am I thinking of, Sean?
Hot air pen?
Blow dryer, yeah, that kind of a thing.
Hot air tool.
I use that for a couple of components with a lot of pins on a previous board that I made, but I haven't used it to solder like a whole side of a board yet.
So it's typically wire solder and a soldering iron.
Yeah, basically.
Yeah.
And it takes a while. I remember last semester I was up till 5:30 a.m. soldering. But that's because, funny story, I was almost done, and then I had I bridged 2 pads, and then I was trying to unbridge it with the soldering iron, and then I look, and then I was digging into the board.
Oh no.
And then I ended up getting ground in power, so
no.
I had to restart, and that's what ended up
just burned right through the mask and right into the board. And
yep. Lesson learned.
Yeah, there's nothing worse too. Like when a pad comes up. I don't know if you had that experience yet. When you're trying to take a component. Yeah, it's not fun because you're like, hey, that wasn't supposed to come up. It's supposed to stay on the board, right?
You try to use the desolder, and the entire annular ring comes with it, and
Oh,
there's nothing left to solder to. Like, oh, whoops.
What's the smallest component size you guys got on there?
Good
06
question.
and 3, I think.
0603.
So it should all be hand solderable, hopefully.
Yeah.
That
With your
QFP
young
looked like
eyes.
QFP looked like it had some pretty challenging pitch to it. What is that? 0.5 or somewhere around there? 0.5
Yeah,
millimeter pitch.
Those look pretty small. I'm not sure
Yeah.
the exact pitch.
You got that in you, Kincaid? You doing 0.5 millimeter pitch by hand?
Dude, I've done actually 01005s. Don't ask me how.
Under a scope?
Well, no, I cheated. So
Under a scope?
under
Yeah,
scope,
imagine that.
of course. No, so I don't even like the microscope, and I hope
You just didn't know how bold the lie was going to be, so at least you said it's with the scope.
I hope this trend changes, because it seems like every person I work with that's older than me or around the same age, they all like the microscope, right? And I bought this amazing monitor. It hooks right up to the scope, and then I look at the monitor and then just do my thing, right? And nobody uses it. So I mean, I was like, what I did was I pulled it off, and then I took this.
It works for you. You like it.
I love it. I don't know how anybody wouldn't use it. It makes it so much easier, especially on the smaller stuff. And so like I pulled it off, and then I took out a toothpick and I dabbed it into the solder paste, and then I put it on there. You wouldn't believe how thick a toothpaste deposit is on a 01005 pad. You might as well have just covered the entire board in solder paste. It was so much solder paste. So then I had to get like the most thinnest tweezer I ever had, and then just dap it a little bit, look under the scope to see like how many balls of solder I had on there, and then I had to go like this along these pads, and I ended up fixing it. But yeah, that's the smallest one I ever did. But I technically cheated but I still had to hand place it and then place it into the reflow oven. So I mean, at least I did that, but I didn't use the actual iron. But that's the smallest ones I've ever done.
Good story.
Small. Yeah, it's my flex.
So
it's my flex in life. You know what I'm saying? So
Yep.
Caleb does that without a scope. No, but I was interested when you said you do it with a scope, because like one of our best hand solders will stay like they like greatly prefer soldering underneath the microscope, and they say that when they're looking at a screen, that two-dimensional only element like messes with them compared to the way a microscope presents it to them. They have a better depth perception looking through the scope than they do up on the screen.
I guess
But that didn't affect you?
I wasn't trained by anyone, right? So I bought this monitor.
Ignorance helped you here.
Yeah, I wanted to use it, and I got used to the monitor, you know what I'm saying? And when I tried to use the microscope, I don't know if my eyes are goofy or what, but I couldn't get the things to, I was always looking through like one eye, you know what I'm saying? It would just, I can't figure this part out, right? So, monitor it is, right? That's it. That's just my thing, you know.
So jumping back to the competition and kind of looking forward to the next leg of that at the actual execution, right? So you guys have done the screen work, and everything always works right on the screen. It looks perfect. In theory is a wonderful thing. What kind of thoughts, considerations, and concerns do you guys have moving into the build phase at SMTAI?
My biggest worry is getting the firmware not work. Like, I feel like there's a lot of components, and like especially the complexity of the additional features is going to add to the trouble of getting the firmware not to crash while we're running it, or trying to get it to drive straight or something like that. Like, yeah, that's just something that I'm looking out for in the future.
Are you going to try to break it?
Wait,
like
sorry, what?
When I write code for my shop, like for my internal system I built, I purposely like try to get my employees to break it. I say try your hardest, throw whatever weird character you want in that thing, press enter when you shouldn't. Try to break it so that way I can
try to put numbers where letters belong, or vice versa.
So that way I can make it almost as much foolproof as I could possibly could. Are you guys gonna try to break it at all, or are you gonna try to just get it to run?
Realistically, that would be like the best idea, but I'm not that experienced in coding, so like once I see something working, I'm just gonna leave it. I'm not gonna touch it.
It's a win.
It worked in the lab. Right?
Yeah.
Yep.
So Ethan, I thought that was an interesting point. You mentioned the complexities of your kind of special feature or add-on feature. So that was obviously critical in you getting to the next phase, but now you have to deal with your brainchild and actually build it, which I think is really cool, because in our industry, the person who makes this complex monster isn't oftentimes the one that has to build it. So
typically they pass it off to some other schmuck, and they're like, "Here, have fun with this." But you guys are the schmucks down the line who have to deal with your design now.
Bite our own bullet.
What about you,
That's cool,
Alex?
though.
What's on your brain heading into the arena?
Honestly, I don't want to think about soldering at all. So I'm also thinking about the firmware. We did order like a couple like test boards to work with, so we're gonna be doing that over the next couple weeks. So hopefully we get something figured out.
I just want to throw this out there because I pitched this ahead of time and they turned me down due to legal reasons. But this
is where it gets good, guys. This is where it gets good.
This project's cool and all, right? But I wanted battle bots, right? So what if your additional feature like pull out like a saw blade and started going after the other competition?
Just
right?
destroy your competition.
Yeah, right.
I would love that.
If it goes and cuts the other one in half, you can take as long as you need to get it through the line.
Signal jammer that just confuses theirs.
Now that's smart. That's smart. That's just send a pulse out, and disable it.
I actually think I brought up EMP blasts, but then there's like a bunch of like other trade show booths going on, right? With like really expensive equipment that would not be happy.
That cause some issues.
Their $500,000 machines just got EMP blasted, right?
The power goes out in the whole arena.
But that's
funny.
cool. Well, I'm excited, man. So you guys are gonna be there for sure then in Chicago.
Yep, we're gonna be there for sure.
That's awesome. And there's a pretty good prize too if you guys win, right? Isn't it a couple
It's like
grand?
2,500.
Yeah, it's not bad.
Nice.
It's pretty good. Well, we will also be there, so it'll be cool to be able to meet you guys all in person.
Yeah,
we've actually got a booth there, and I think if you guys can work out a time, maybe we can do a quick little filmed interview with you, and I think that'd be awesome. We're in booth 2403, so reach out as it gets closer, and we will figure out those details. But I did have one question I wanted to ask you guys, because one thing our industry talks about a lot is kind of the age gap, right? There's a lot of, you're looking at three guys, at or darn near 40 with, young children and mortgages and, kind of mid-career range. And we're generally considered like the younger folks
yeah, they
in the
call
industry.
us young, so
yeah. So there's this pretty well identified kind of age gap between, those who are very late in their career and, the next that are coming up. So as an industry, I think we have a desire to reach people your age. And obviously this program was a good way of doing that and has got you engaged. But what, for our audience, what are things that you believe the industry can do better to kind of engage and support your generation as you guys kind of, consider and find your career paths? How can we hook you and bring you in?
For me, I think coming to colleges and showing what industry you're in is about, like that would be a big factor to help. I went to this fair at my college, and then I saw, this isn't really industry, it was more academia, but regardless, it's the same thing. I saw this booth that was advertising stuff about the Minnesota Nano Center, and then that's what got me interested in all like the nano fabrication stuff, semiconductor fabrication. And then
Nanoscale anything is sick, right?
yeah.
Yeah.
And then we ended up like talking a bit, and then I ended up getting a job there this summer, so
Nice.
it was
Congratulations.
pretty chill. Yeah.
So come
Yeah.
to you. Don't expect us to come you to come to us. We need to meet you where you're at.
Yeah. I feel like college students have like mainly school on their mind.
Mhm.
So
Yeah.
if it's not right in front, it's like it's hard to grab their attention.
Where are you at with all that, Alex?
I do like the idea of, or from my perspective, because I think there have been like some companies that come for like company talks, and they just come and they have a couple employees to come down and they share what their company is about, and like they do a whole presentation. Sometimes they do like resume reviews as well. I think that's really helpful, and but I also feel like another thing is just like what you mentioned, like it's that age gap, and with that age gap comes experience, and like talking to like even like a professor, like someone in the industry, like I just realized that like, dang, I don't really know much, and I feel like that's really hard to overcome without getting that experience. So it is on the students as well, like maybe get internships or co-ops or stuff like that.
My advice would be don't be afraid to ask, because like I'm only 4 years into this industry, and my experience has been that like when I enthusiastically engage with people who have been doing this for decades, they're eager to share their knowledge and help bring me along and pass that on. And they're happy to see somebody who wants to like follow in their footsteps and kind of try to take their knowledge base and move it forward and stuff. So most of the people who have been doing it for a long time are like just dying for somebody your age to show interest and ask them like what they could do to help you. Like people are eager to do that. So just give them the chance.
Yeah, and I think even us where we are in our careers now, there's still some folks that we'll talk to, and we probably feel a little bit of what you just described still, right? Because there's dudes that have been doing it for 45 years and have been involved in the actual formation and conception of the technologies that we're trying to play with. So it never ends, if that makes you feel any better.
It is something.
Yeah,
Well,
I think about John Burke, right? Like the guy invented laser soldering in the 80s, and we were talking to him like, how do you like? And I still don't even really understand how that
No,
works.
we talked to people at Apex
Yeah.
who got involved with the formation of surface mount components.
Right,
like when that
right,
was
right.
first becoming a thing. Like
Right.
it's crazy.
Yeah.
well, this is awesome. It's been a pleasure having you guys out on. And when Tara reached out about it, I know we were all excited because this is something that's easy to be excited about. It's just cool, and I think it's super impressive to see what you guys have done. And I can't wait to see those things in action. And I think we'll all get a chance there. If people want to follow the work that you guys are doing, if they're interested in kind of seeing this whole process through, what are the best channels that they can kind of keep in touch with you guys and watch the next steps?
I think maybe LinkedIn.
That's a good one for our listening audience. Yeah, so I think you guys are both on LinkedIn. I was stalking you a little bit as I was putting the show notes together, so people can reach out and contact you there, connect with you there. Good on you guys for doing this.
It's called being a follower when you're not doing it the creepy way, Elias, on LinkedIn. Right. It's kind of they've normalized it if you're not weird,
I was in incognito mode, but
nice.
Good on you guys for getting involved in this. I think if and when the time comes for you to enter the industry, it's a hell of a thing to put on your resume, and there's going to be some familiarity with your names and faces after this. So on behalf of Sean and Daniel and Paul and myself, thank you guys for joining us. We'll look forward to seeing you at SMTAI, and we hope to see all of our listeners and viewers there October 19th through the 23rd. If you needed yet another reason to register, you can see these bright young men operate their robot, or their robot's going to operate itself. So smtai.org, booth 2403. Thank you.
Follow us on YouTube, all that.